Now we will discuss about the pin description of 8051 microcontroller. As you can see, there are 40 pins in the chip. So starting from the pin number 1, uh, we will go to 20, and from 21 we will go to 40, like this way. Okay. Now uh, starting with the pin number 1, you can see this port 1, P1.0 means port 1, and as we have discussed that each port is containing 8 pins or 8 IO lines. So this you can see P0 to I mean P1.0 to P1.7, from pin number 1 to pin number 8 there are 8 pins. Pin number 9 is reset pin. As we are if we apply some positive voltage here in the pin number 9, then the total program will start over. Means it will I mean the 8051 microcontroller will start its execution of program since the beginning, very beginning, that that is 0000H. Now coming back to the pin number 10 to pin number 17, there are port 3. That means, and there are dual activities of these pins. Like P3.0, there is port 3, first pin, that acts as the receiver, whereas 3.1 will act as a transmitter. That is, P3.0 and P3.1 is acting as the serial communication device. And there are two interrupts, that is P3.2 and P3.3. There is pin number 12 and 13. Those are active low. That means when this signal is low, that this pin is activated. Similarly, pin number 13, that is P3.3. Now two timers are there, as we have discussed. Two timers or counters are there. So it is denoted by pin number 14 and 15, P3.4 and P3.5 respectively. So again, RAM is there. So read and write operation must be there. So pin number 16 will represent write, and pin number 17 it will represent read. 18 and 19 pin is used for the crystal oscillator circuit. And as we know, if notch is here in this side of the IC, then the ground will be pin number 20 and pin number 40 will be VCC. So we'll go by this. Pin number 21 to 28, that represents port number 2, and this is very significant, that A8 and A15, that means the higher 8 bits of data, I mean the address, that is denoted by this P2 port. Pin number 29, that is PSEN bar, the complement. Pin number 30 is ALE bar slash PROG. Pin number 31 is EA bar slash VPP. We will discuss the operation of pin number 29, 30 and 31 just very soon. And pin number 32 to 39, that denotes the port 0. That port 0, uh, as you can see, this port 0 is the multiplexed address and data is multiplexed. So this AD0 to AD7, that is the lower 8 bit of the address and the data are multiplexed, and that is represented by this P0. Now we can clearly go back to the previous one, this one. So you can see the significance of P0, P2, P1 and P3. So in this case, P1 and P3 are in the same side, and P0 and P2 are in the same side, so that this configuration was in the block diagram. So perhaps it is clear. So we will go to the operation of the pin, that is pin descriptions. So out of these 40 pins, 32 pins are for input output operation. That is P0, P1, P2 and P3. So each port contains 8 pins. The rest of the pins are like VCC, which is connected to the plus 5 volt, that is activation voltage, ground, that is that needs to be grounded, XTEL1 and XTEL2, that was in pin number 18 and 19. So this needs to be connected with the crystal oscillator. Reset circuit, if we apply the positive voltage in this pin, the microcontroller will restart just like the restart button of the desktop or laptop. EA bar and VPP we will discuss, and the rest of the pins. So this, coming back to RST pin, this pin number 9 is the reset pin. This is the input pin obviously, and it is active high. When we will apply some high pulse, there is positive voltage, that 8051 will reset and terminate all the activities, and it will start executing since the beginning, that is 0000H, or the beginning of the program. And this EA bar and VPP, this pin number 31, is a very important thing, as we know that the on-chip ROM is only 4 kilobytes. But as 16-bit address bus is there, so it can address 2 to the power 16, that is 64 kilobytes of data. If the program length is more than 4 kilobytes, then what will happen? Then we have to connect an external device, external storage device, external memory device. So ROM is not available in the market. Available in the market is RAM. So we should connect externally a RAM, and then it contains some programs. Okay. So if this EA means external access, if this EA oblique VPP, EA bar oblique VPP, that is pin number 31, that is grounded, then EA bar pin will be high, that is active low, so that it is grounded means if the program length exceeds 4 kilobytes, then external memory should be connected. As external memory is connected, so this A bar pin number 31, must be grounded. Okay, and otherwise, if the program length is within 4 kilobytes of ROM, then it can be connected to some high voltage, I mean high pulse, that is plus 5 voltage. And this VPP signal, you can see this EPROM programming, when the I mean at the time of program burning inside the microcontroller chip, then we can use this kind of high pulse in the VPP pin. Now this ALE oblique PROG bar, this address latch enable pin, that is the output pin, and it is active high. This pin is used for the demultiplexing of the data and address. What is the purpose? I mean the application of address latch enable signal by connecting the enable pin to the latch circuit, latch IC, that is 74LS373. And PROG bar is used at the time of the program EPROM programming, that is burning of the program inside the burner. A 50 millisecond pulse is to be connected with the ground through this pin for the programming. So it is purely connected, I mean purely related to the burning, that is program burning in the burner. PSEN bar, that is also a very important pin, pin number 29, that is program store enable. This is the output pin and connected to the external ROM if the program length exceeds 4 kilobytes of space. Now we will start analyzing the oscillator circuit. As we have already discussed, pin number 18 and 19, these two are for dedicated crystal oscillator circuit. And in the block diagram, if you can remember, this crystal, the crystal frequency is 11.0592 megahertz. These crystals are connected with this XTEL1 and XTEL2, that is pin number 18, pin number 19, and it is grounded via a 30 picofarad capacitor. But in practical, when we will implement some circuitry, we will design some circuitry, we cannot find 30 picofarad capacitor. We will find only 33 picofarad in market. There is also, we can see these capacitors are not polarized. So we can use 33 picofarad of paper capacitor or disc type capacitor. So these capacitors are, what is the purpose of this capacitor? The purpose of the capacitor is to stabilize the output of the crystal, that is the frequency. So frequency must be stabilized by connecting these capacitors in parallel with the ground. Okay, so these oscillators, when this external frequency source other than crystal oscillator that needs to be connected with xtel, it will be xtel, there is a small spelling mistake, this is xtel1 and xtel2 that are left unconnected. xtel2 will be unconnected and external pulse should be connected with xtel1, and the time to execute a one single cycle of instruction is given by this t, that is c, that is the into 12d by the crystal frequency. Here d will be 1. So this is the circuit of external clock source. So this is the timing diagram. You can see this is the oscillator circuit that is connected with the 11.0592 megahertz crystal, and these are grounded by a 30 picofarad, in practical 33 picofarad capacitor in parallel. So this is the oscillator frequency and this is the address latch enable. So one machine cycle is represented by this one. This disc type capacitor is also called a ceramic resonator oscillator. Good morning, students. In earlier classes, we have seen that the block diagram of the 8051 microcontroller, the pin diagram and pin description of 8051 microcontroller, and there are some differences between microprocessor and microcontroller. Lastly, we have a quick view on the crystal oscillator circuit. So today we'll discuss about the reset circuit. Now, before going to this table, we'll come to this one. Now, figure number 4.3b, it is clearly seen that to the RST pin, that is pin number 9, that is connected to an 8.2 kilo ohm resistor to ground, and another part of this joint is connected to plus VCC via a 10 microfarad capacitor, and in addition, in parallel with the 10 microfarad capacitor, there is a switch. Okay, now this VCC means plus 5 volt, and the capacitor 10 microfarad capacitor is a polarized capacitor as is shown here also. The positive leg will be connected to plus 5 volt or VCC, and the negative part will be connected to this 8.2 kilo ohm resistor. Now what happens? If we press this switch, then what happens? The voltage, I mean the current will come like this way. Okay, because this path is closed in this way. So a positive pulse will come to this pin number 9. Now we can ask, you may arise a question that why this current is not flowing through this 8 kilo ohm resistor. It is because this is shorted. This is a simple wear, but this is a resistive wear, where it clearly seen, it's clearly seen that among these two connectors, whose resistance is greater, this resistance is greater, and you know that current will flow through the lowest resistance path. So this is the lowest resistance. So the current will come like this way. Okay. So this 9 pin number 9 will get a positive 5 volt pulse. So it will be reset. Now what we have learned, that if if the path is if the pin number 9 is connected to plus 5 volt, then the content of microcontroller will be set reset to 0. Okay. Now here you can see the program counter, accumulator, B register, program status word and data pointer. These registers will be reset to 0. Only the stack pointer will be reset to 0007H. Okay. Please be clear about that. After reset, the stack pointer value will not be set to 0000H. Now, why? It will be discussed later. So, this is the reset circuit. Now, we'll come to the IO ports. Now, earlier we have seen that the IO ports are nothing but it can be used for input purpose or output purpose. By default, if we press the reset switch, you can see this is configured as the output port, and there are four ports. You know, there are four ports: P0, P1, P2, and P3, and each ports are having 8 pins. Okay. Now, to use them as the input port, it must be programmed. Okay. Now, how it is programmed? We will come to the programming part. Uh, and all ports, this is the advantage of this IO ports. This all the ports are bit accessible. Means you know that if we you know that this port 0, suppose take port 0 are having 8 pins. So if we want to make any particular pin port 0 second pin, we need to make it as input port, we can access it, or output port we can also access it, that is bit accessible. Okay. Now this P0 port we will discuss in a quick depth. Now P0 port may serve as inputs, outputs, and when used together in the, if you can remember the pin description of 8051 microcontroller, then you can see that as a bidirectional lower order address and data multiplexed are there. So P0 ports are nothing but address data multiplex. So when these P0 ports are used together, then as a bidirectional lower order address and data bus for the external memory. To configure this to the input port, this P0 port must be connected to logic 1, that means high voltage, and it is used as a data bus during the internal EPROM programming. This is the characteristic of P0 port, and this is the circuit connection of P0 port. As you know that P0 port are uh, need to be connected with the pull-up register for activation, otherwise they cannot be activated. Whenever we want to use this port 0, then we need to connect a pull-up register. Here in the circuit you can see the pull-up register value is 10 kilo ohm. This is the register bank. Okay. Now these other ports, these P1 and P2 ports, they also can be used either as input port or output port. And the important thing is P1 and P2, these ports doesn't require any pull-up register to activate these pins. Now P2, port 2 supplies the higher order address, as you have seen in the pin description. Now this higher order address bus, that means A8 to A15 for external memory or input output devices, any input output devices. And the speciality of P3 port, this P3 port 3 may be used as an input port or output port as P0, as is it was in P0, P1 and P2, port 1, port 2, port 0. Now the alternative uses of P3 are shown in this table. You can see This was earlier it was seen in the pin description, the diagram, pin diagram. This P3.0 and P3.1, that means first and second one, that used as the serial controller, serial transmission, serial communication ports. That is reception, that is RxD, and transmission, that is TXD. That serial data input and serial data output. Now, for transmission, it needs to be acts like an output, and for reception, it needs to be acts as a input. And both the pins are related to this SBUF, serial buffer register. This is the special function registers. SFR means special function registers. Now, P3.2 and P3.3, the third pin and fourth pin. This is the INT0 and INT1, both are complement, INT0 bar and INT1 bar. These are external interrupt 0 and external interrupt 1. While discussing the block diagram of microcontroller 8051, we have seen that there are two external interrupts. There is internal interrupt 0 and interrupt 1, and these are related to timing control register. We will come to this timer control register while discussing the special function registers. Now P3.4 and P3.5, that is timer 0 and timer 1. As we know, in microcontroller 8051 there are two timers are there, and they are connected to TMOD register. This TMOD, TCON and serial buffer register, these three are special function registers that will be their internal construction and working will be discussed later. And P3.6 and P3.7 denotes read and write. That read and write both are active low. That bar will be there. And external memory write pulse and external memory read pulse is denoted by P3.6 and P3.7 respectively. So we have completed our pin description and the block diagram, the basic difference between microprocessor and microcontroller. So we will see you tomorrow.